Welcome to Ask and Learn.
So in this problem we have a bent rod that is supported at 3 points, and there is an external load applied at a point. So we have reactions at the 3 supports, and at the first support we have reaction forces in the x and the z direction, and that would be at point A in the figure. And that point is minus 2 meters in the y direction. At the second constraint, we have constraint forces in the y and the z direction, and that would be point B in the figure, and that has a position of minus 2 meters in the x direction. And at the third constraint, it has constraint forces in the x and the y direction, and it is at a point minus 1.75 meters in the x direction and 2 meters in the z direction. Now, we're given the magnitude of the externally applied force, and then basically the angles that would kind of describe the direction in spherical coordinates. So if we just kind of, the best thing to do is kind of map it back into the xy plane, and then take components. The z one is easy because that's just sine of theta, in that I think that's actually a minus sign. I messed that up. I think the answers are still correct. Yeah, I just copied it down wrong for my solutions. And then you can project that vector into the, let's see here, the xy plane, and then project it onto the x and y axes. So this is the direction of this vector that has a magnitude of this value, which in the book is given as 800 newtons. And that vector force acts at the origin of our coordinate system. So we have 4 equations, or not 4 equations, we have 4 forces and their position vectors. We have our force balances and our moment balances. And in this case, we're going to have 6 non-trivial equations because we have 6 unknowns here. So we're going to get 6 equations for those 6 unknowns. And going through the algebra is just cranking through the stuff. We get that at the location A in the figure, the force is minus 400 in the x direction and 800 in the z direction. At the see here at point B in the figure, the force is 600 in the y direction and minus 107 in the z direction. And at point at C in the figure, which is I've labeled 3, it is 53.6 newtons in the x direction and minus 800 newtons in the y direction. So because of that, the weird geometry here, it's hard to really figure out if these make perfect sense. Obviously, the orders of magnitude are fine because our load was 800 newtons. We can see that actually value shows up here a couple times. It's not exactly clear why that is, but again, just because of the complicated geometry, it's very hard to use your intuition to completely justify these answers. Just that their orders of magnitude seem correct.